final opportunity to ask questions. It's two excellent talks. There are no questions online at the moment. Any questions on the floor? Okay, that's good because I have 7 questions per speaker. No, I don't. I'm just a little panic. I have 1 question for each speaker. My first question is to Francesco. Congratulations, really interesting work.
Thank you.
As a hepatologist, we are quite interested in monocyte dysfunction in the context of hepatitis liver failure outside of cancer, because we do see that with risks of sepsis and things. Other than co-culture, did you think about any other techniques to look at monocyte function, like prostaglandin signaling or something?
Actually, at the moment, we were actually interested in just the role of monocytes in altering chemotherapy response. What we wanted to do is actually to find candidates associated with the role of monocytes in affecting cancer response to chemotherapy. So at this stage, what we are actually trying to do is just to focus on this and trying to investigate potential candidates that are involved in this role. So specifically now we are developing a model just to manipulate in vitro these candidates that we identified by transcriptomic profiling in order to validate our findings by RNA-seq. But in terms of functionality, just related to the monocytes per se, that can be phagocytosis, I didn't do any investigation related to that.
Okay. And I have a question for Izzy. Very pretty prize for the prettiest slides of the whole conference. Very, very nice. I just wondered if you've looked at any control tissue. So, for example, PSC without cancer, or colonic polyps, or adenomas, and compared them to colorectal cancer and liver cancer.
Okay, thank you for that. We haven't actually looked at any PSC controlled tissue. It's a good idea. We haven't looked at polyps either. What we do have with our non-CCA, non-cholangio tissue, anyone who's looked at cholangiocarcinoma tumors down the microscope knows that the bile duct is quite narrow. So when you're trying to select areas to get non-tumor tissue, it's really difficult to get just bile duct. Usually you end up getting quite a large chunk of the liver. And what we see quite nicely in, because we have some patients who have no background pathology recorded, no background clinical disease recorded, and on their background liver, you see PRH and phosphorylated PRH lighting up quite nicely in the rest of the liver. So, and it ties in with what we know that about PRH being necessary for proper liver embryogenesis. But you're right; it would be interesting to look at PSC.
Looking at colonic adenomas, for example, or inflamed gallbladders that aren't cancerous, from cholecystitis, for example, maybe as a comparator.
Yeah, I think one of the restrictions is the nanostring technology is so expensive to use. So it might be that we start off using something that's relatively cheaper. So maybe like the vector analysis, it's only 7 colors, but you can get a lot of information out of 7 colors before we scale up to using nanostring.
Simon?
It was just a question on spatial. I mean, if you had your time again and the money, would you do CosMx or would you do GeoMx? Or do you think ultimately we've got to do both to get the best answers?
I think it depends on the question you're trying to answer.
Because ultimately, because you can't really decipher at the ligand level adjacent, you can't deconvolute really with the GeoMx, can you?
Yeah, you can't.
But you get a better idea what's going on in a geographical patch of the tumour. So I find it quite hard to know what's the best technology to invest in, or whether ultimately we're going to have to do both experiments. But
I think one of the things, and I was saying this to someone earlier. One of the things about cholangio is there is so much we don't know, and a lot of the evidence we have comes from treatments that have failed or stuff that hasn't worked. And I think something that's missing, but would be a huge resource going forward, even for future generations in this. I sound like I'm 70. For future generations in this research field, is understanding what the biology of the actual the tumor and the tumor microenvironment is, and that's where things like the geomics are helpful, because apart from giving you information about what's going on, it's a huge hypothesis generator, because you start to ask the questions when you can see what cells are in the vicinity of each other. And you're right, it's possible that we can do some deconvolution further down the line, but I think it's a good starting point, I think, yeah.
No, thank you.
I have a further question for Izzy. I mean, when you look at your PRH, do you have any data to suggest that it can be dependent on the microenvironment? And if so, are you planning to select your ROI accordingly and group, according to when in the area of the tumor they are?
Yeah,
do you think it will make a difference or not?
That's a really good question. I think it will make a difference. So Sheila and Kevin have some preliminary data that shows that PRH is also linked to signaling pathways, including interleukin-6 and TGF-beta. And we know that these are pro-tumor sort of cytokine signature, not just in cholangiocarcinoma, but in other tumors as well. So I think that'd be a good starting point for us. So one of the exciting things about the immuno-oncology panel is just the sheer number of things you can probe. You can look at cytokines, you can look at integrins, you can look at signaling pathways. So yeah, it's really interesting, I think.